This is not on the folder. Yeah, this is just, I just wrote this a few minutes ago. So is there anything wrong with what we're seeing here? Main is down below. It's just calling these two functions. Yep.
I don't know, this is a guess, but is it possible to create and join in different contexts?
So create and join are in different functions, but that's fine, right? Because the function is going to get created, and then once we call join, we're just going to wait. There's nothing else in between. Okay, other guesses? Yeah.
Consider a null statement at the end of.
In here.
Yeah.
So we're passing ID as a parameter to pthread create. So that's why we replaced the null with the actual parameter. Right? Yep.
Does it need the dereferencing for thread on line 18?
So it takes a pointer and it is a pointer. Oops. So recall the syntax for pthread create is the thread, attributes, function, and argument. The fourth one is the argument. So if we don't pass arguments, that one would be null. If you want to pass arguments, then that one should be whatever you're trying to say. Any other guesses? So here's a question. When we create ID, where is ID going to be stored? Yeah. Yes. So ID is going to be stored in the stack of create thread. What happens when create thread finishes up? It's going to clean up its stack, and ID is gone. But who still has a reference to ID? Our thread function, right? So I've seen this mistake in both your assignments and your projects. So memorize this. If it's allocated on the stack, don't pass it around. Okay? If it's allocated on the stack, you shouldn't be passing it around. Questions? Okay. So now that we have gotten that out of the way, we will start by solving the parallel add part of this question, of this exam. There's 4 exams. This is the pthread creation question, and it involves some semaphores, so it would be a good idea to actually just do this. So here's a quick overview of what we are looking for in this exam, in this problem of the exam. We have a file, a big file. It's composed of a set of digits. So basically, like for example, 1, 2, 3, 4, 5, let's say 100. Okay? So the way the code is written now is it reads a chunk, let's say 5 numbers. It puts them in an array. 1, 2, 3, 4, 5. And always the first element of this array is the size of, or not the size, but how many numbers follow it. So if we have 5 numbers here, first element is going to be 5. Okay? Now, what we're going to do, we compute this. We use a function called slow sum. We compute the sum of these 5 numbers. these by 5 numbers. And then we do the same thing. We read the next 5 numbers. 1, 2, 3, 4, and 5. We call slow sum on these. And then eventually we're adding all of these together to the total sum of the entire file. So our goal at the end is to sum all of the digits in the file. How we're doing it is we're doing it 5 by 5. We take the first 5, sum them up. Then take the second 5, sum them up, and add them to the previous 5. Third 5, sum them up, add them to the previous ones, and so on and so forth until we get to reading the entire file. So as you can guess probably by now, the change we want to make is we want this to become a thread, this to become a thread, this becomes a separate thread, and then we're going to collect total sum from these threads. Okay, so back when we first introduced multi-threading and multi-processing, we kind of did a very similar problem. We did this exact same problem in which we were subdividing the threads or the chunks of arrays into threads. So we're going to do that, but with a little bit more constraints at the end of this problem. So if I tell you there's, let's do it this way, there's 100 digits in here, and I want my chunk size to be 5 elements per chunk. How many threads would we need? Yeah, 20. So keep that in mind that we end up with 20, which is 100 over 5, 20 threads. Okay, so we're going to have to create 20 threads that are going to sum chunks of 5, and then we need a way to actually collect all of that information and put it in a total sum. So how would you recommend that we do this part, which is managing total sum? Can we just say in each thread function, total sum plus equals whatever you summed locally? Or is there a problem with that? Yeah. Yes, it's going to create a race condition on total sum because all of the threads are accessing, updating total sum at the same time, or they might be. So that's going to create problems. Okay? So there are 2 solutions possible for us in this case. What are those solutions? You can start with whichever jumps to mind first. Yeah.
Just have each slow sum have its own temporary, and then at the end of it, have it just lock whenever it's just adding a separate variable.
Yep. So the idea would be just to lock access to local sum. Okay. Is there another way to do it? So thread 1, so solution 1 is basically lock access to total sum using a semaphore or a mutex, whichever way you prefer. So is there another way that pthread allows us to do this thing? Can we avoid using semaphores in this case at all and do something else? Yeah.
You use their output variable.
Yes. So you can use thread return variables. So what's going to happen is that pthread join so takes the thread as first parameter and the return value as the second one. And we can save each local, we can read each local sum from the return value and then have main compute the final sum. So in this case, since only main axis is total sum, we no longer have a race condition. So we don't need semaphores anymore. Okay? So this is parts 1 and 2 of the problem. So let's go ahead and start thinking about how do we implement those, and then we'll switch back and see how things go. So this is in parallel add in exam 2, 2020. So before we get started, I'm going to give you a couple of minutes to read this piece of code and let me know what this piece of code is trying to do. Yeah, it's making the chunks, right? So, yeah. So what is actually happening in here is that we try to read chunk size bytes out of the file every single time, at most chunk size bytes. We take how many bytes we read in the read results, and we put it in the first entry of the chunk. So recall that the way we're creating things is that this guy is the number of elements to follow. So that's exactly equal to the number of bytes I read from the file. So I put that in chunk and size at element 0. And the chunk, this pointer arithmetic operation, simply, this is chunk and size. I'm going to call it C and S. Chunk and size plus 1 is just going to start at 1. Let me use a different color. So here, this is chunk. Now, when I say chunk at 0, what does that map to? Which element of chunk and size? Yeah. So chunk at 0 maps to chunk and size at 1, and so on. Okay. Then we're just reading the values, converting them from ASCII to integers. So that is pretty straightforward. And the way we're doing things now is that we're adding the slow sum. We're adding total sum equals to total sum plus the slow sum at every single time. What we want to do now is we want to parallelize this piece of code so that the slow sum is done in each and every individual thread. So where do you think our pthread creates should go? There are several options. We can create them outside of the loop. We can create them inside of the loop. We can create them after the loop. So where do you think we are going to create our threads? A few more seconds. Okay, go ahead now.
The line you're at right now.
Yes. So this is where we're doing each of these separate operations. So this is where we want our threads to begin. This is where we're going to create our threads. So in here, I will just write pthread create, and we're going to fill that out later on. Okay. So what do we need to do to slow sum, to turn it into something that a pthread can run? What changes do we need to make to it? Yeah. Say that again? Yes. So step one is this guy is going to have to change to return a void pointer. And then also it accepts its first argument as a void pointer as well. Okay? So recall that the thread function's signature has to be return a void pointer, accept a void pointer. All right? So next up is we lost our integer array in this case. So we have to recover our integer array. And the way we do that is we say data is simply we cast the void pointer into an integer point. Integer uint 8 underscore t means it's an 8-bit integer. Okay, so we just casted that one and we are back in here. And then instead of returning sum, we are going to return null. All right, questions? Yeah.
Why are we returning? Wouldn't we want to return some, but as a void pointer?
Yeah. So we're just gonna do technique 1, just because we're just more practice with semaphore, so we're just gonna do that. Yeah, but instead, if you wanted to use the other technique, then you should use pthread exit, and then you must allocate and malloc your sum. Okay, so let's go ahead and create our threads. How many threads do we have? So if pthread t threads, if the size we set of the file is, we already defined as max file size, we divide that by the chunk size. Yeah. So the reason why I'm saying that you need to malloc space is basically if you return this sum, then you're returning a pointer to something that's going to disappear again. So that's why you need to malloc it. So is this correct? Is max file size over chunk size correct? Yeah. Yeah. So if it's odd, if it's not odd, if it's not an exact multiple of chunk size, then we're creating one thread shorter, right? So we want the ceiling of that one, or we can just be conservative and add a 1 to it. Right? So if we create one more thread, who cares? Or one more thread, but we don't create it, it's not that big of a deal. Okay. So we also need to track our threads. So I'm just going to initialize the number of threads to 0. Then we can call pthread create. Okay, questions? All right, so are you all convinced that this is going to work, or is there something we're missing? Are we doing something incorrectly? Yeah.
Are we not? I don't remember ever adding it back to the.
Yes. So first thing we want to do is we want to move total sum to become a global variable. And then add a semaphore, let's call it lock. What's the initial value of the lock if we're initializing it as a semaphore? 1. Okay, so be careful about the initial values of a semaphore. If you want your lock to be unlocked initially, initialize it to 1, right? So keep that in mind as well. So next up is we want to add the local sum. So we're just going to do pthread or sum bar okay.
Use the weight as.
Oh yeah, my bad. Wait and pause. Sorry. Yeah, thank you. Questions? So anything else we must do? Is this all looking good? Should we go ahead and run it, or is there anything that's kind of catching your eye? Yeah. Yeah, so we're passing chunk and size. What's the problem with passing chunk and size? Yes, exactly. Right, so look here where chunk and size is defined. It's defined on the mains stack. Right, and we just said at the start of this lecture, be careful about sharing things that are on the threads stack. Right, it's not stable. You don't know if your code is going to work, and you have to be very careful about that. So instead, we must allocate this on the heap. So we're just going to do chunk and size and allocate this times chunk size plus 1. Okay. Now, anything else? Say that again. Yeah, so we're creating a chunk and size, and we're not freeing it. So we have to make sure we free everything. But before we get to freeing, how many chunk and sizes should we have? So yeah, 1 for each thread. How many are we creating? Just 1. So we need to make sure that each thread gets its own chunk. So what we're going to have to do here is we're going to have to allocate again. Yeah, let me get that from above. So every time we allocate a new buffer for each thread. So the first thread that goes in gets this buffer, the one defined at line 173. And then at the end of each loop, we create a new one so that we pass that correctly. So where would you suggest that we free those buffers or those chunk and sizes? Where would be a good place to free all of those? Say that again. So if I want to free them on join, I must keep track of all of them, right? I must put them in an array and keep track of all of them. Is there a better place for us to do that? Does each thread, or the other question is every thread, once it's done, is there anyone else that's going to use that buffer again? Nope. So pretty much I can go up to the end of the thread function and just free the data in here. Okay? Questions? Okay. So now I think we should be able to compile this. I missed an and. And we also missed to join for those threads, right? I less than num threads I plus plus p thread join threads at I. So we created the threads, but we weren't waiting for them, so we missed to add the join statement. Yes. Yeah. So here's the trick in here. So when we, let's assume this is the file, all of the file. It doesn't look right. Let's see, this is the entire file. So what we're saying is we're going to split this up into several chunks. And we want each thread, so this is, let's say, thread 1, thread 2, thread 3, and thread 4. We want to create a chunk for each thread, copy the information from the file, and then let it sum. For thread 2, it's going to have a different chunk. It's going to sum that one. Thread 3, again, different chunk, and then edit that one. Thread 4, a different chunk. So each thread must have its own chunk in there. The reason why, so basically, if we had only one malloc, we end up with just one chunk. So we can't have all of them accessing the same chunk. We must malloc for each thread in a sense. So the first thread is going to use the one on line 174. So anytime I create, so basically line 174 is consumed at line 196 the first time. So that's why I reallocate again after line 196 to make sure the next thread gets its own chunk. Does that make sense? Yeah. Okay. Yeah. Okay. So I think now we should be good. Always missing that null at the end. There we go. All right. So to run this, you should pass 2 or whatever number you want your chunk size to be. And then we should pass test file 1, for example. As you can see that we have 3 threads. 2 threads are summing chunks of size 2. 1 thread is summing chunks of size 1. And then eventually we get the full sum at the end being 15, which is the sum of 1, 2, 3, 4, and 5. Okay? Questions? So we have done something very, very similar to this one in our previous discussions on multi-threading and multi-processing. Now, the next thing that this is enforcing on us is the following. This is step 3 of this part. What step 3 is saying that you cannot have more than max number of threads active at the same time. So let's say we were still doing the 100 with a chunk size of 5. We need 20 threads. So eventually we're going to have 20 threads active at the same time. What this problem is telling us is that you cannot have more than 5 threads or active at the same time, or 2 threads active at the same time. So your job is now to use semaphores to make sure that at most two threads are running at the same time. So how do you suggest we do this? Yeah. Yes, exactly. So what we're going to do is we're going to use a counting semaphore. So we're going to initialize. Let's create a new one. Thread sem. And I think it's called max threads. So the initial value of our semaphore is initialized to max threads. So if all of these threads are waiting on this semaphore, at most, max threads of them will go in. And then once one posts, the other one can join. So if we lock on this entire thing, and then unlock in here, oops, some post, thread some, and we make sure that at most we have max threads at the same time. Okay? Yeah. Yeah, so that's the follow-up question. So the text is telling us that this is step 3. So instead of, we don't want to create all of those threads at once, right? So now what's happening is that we're creating all of our 100 threads, but 98 of them are blocked and 2 of them are running, right? And then once those 2 complete, the next 2 are running and then 96 are waiting. So we don't want to waste all of the resources on those 96 ones. So how can we change our code so that instead of the threads being created and blocking, that we only create them when we need them? Yeah. Yeah, so we have to have a wait before our creation, right? So we can just actually move the wait to here. Where is that? In here. And that's pretty much it. So we go into pthread create at most 2 times, then we block. Once those finish up, they're going to post to us. We go to then there twice, we're stuck. So on and so forth. So at most, we're creating 2 threads at a time. Yeah.
Would we want to part close, like right after they join?
So if you move your post to after they join, are you ever going to reach that piece of code then? You're probably going to be stuck waiting, right? So you create your first 2 threads, then you're waiting, and no one is going to post, right? So you want to post before the thread leaves, and then make sure. So it's okay if it posts and then it's swapped back in, and then it exits. That's perfectly okay. So let's make sure this is correct. Oops. So now the difference between this one and the previous was that the following. We started summing 3 threads at a time, and we finished those concurrently. This time we started 2 of them. Once those 2 finished, we started the 3rd one, and so on. Questions? Okay, good. So we finished off early. So let's start with doing one of the other questions. Let's take a look at, so before we do that, let me give you the difficulty rating of these questions. They are polite threads is the most difficult in terms of semaphores, followed by the road, followed by downloads. So if you want to measure yourself how much time you're getting, you should fly through downloads, hang up a little bit on road, and then spend quite some time on polite threads. Okay. So let's do the road one, the middle. Downloads is the easiest. Yeah. Well, if you studied well enough, both downloads and road are quite straightforward. But I'm just saying, if you're trying to come up with the solution on the day of the exam, that's the difficulty. So here's what we have here. We have a highway, and then here's the problem. We have cars coming in from, let's say this is northbound, this is southbound, or the other way around. Let's say southbound, northbound. What we're saying is that only one type of cars can be on the highway at one point in time. So if northbound cars come in and they see no one on the highway, the first car can go in, and then after that, as long as there's a northbound car on the highway, no southbound cars are allowed on the highway until everything is finished. Once all of the northbound cars finish up, then the southbound ones can start. And the same thing, as long as there's a southbound car on the highway, northbound cars are not allowed to enter. Okay, so our job is to use semaphores to enforce this constraint on our cars. So how would you suggest we do this? Yes. Yeah, so we're going to use a semaphore. How many semaphores do we need, and how are we going to implement those? 3. Okay, so 3 semaphores. This is kind of like which problem we were trying to do. Can you say that again? The party one, right? So the party with the students and the janitors. So this is very similar to that one, except in here we don't care about starvation. So it's said in here that this system has the possibility of starvation, but we don't care about that. You don't have to worry about it. Okay, so what do we need to keep track of, and how would we implement this? Yes. Okay, so we need to know how many southbound cars are there, how many northbound cars are there. And how are we going to coordinate that? If there's a southbound car, no one is allowed to go in except southbound cars. If there is a northbound car, then no one is allowed to go in except northbound car. If there's no one, then you can go direct. Yeah.
If you're the first car in your direction, you lock,
Mm-hmm.
and then wait for it to be unlocked again. So you lock, wait for unlock.
And then when do you unlock? Who unlocks?
Oh, unlock the last person. Sorry.
Okay, the first person locks, last person unlocks, right? First car locks, last car unlocks. So let's go ahead and think about this. The first southbound car comes in. If it's the first one, it's going to try to lock the highway. But before it does that, it's going to lock southbound ones. So this is southbound car. It's going to grab a lock on the southbound cars. And if it's the first one, it's going to try to lock on the highway. If the highway is empty, it's going to go through, and then all of this unlock the southbound. And then everything is going to go through. So remember, this is very similar to what we said, that the first student that goes in is going to post a sign that says students are inside the building. The last one that leaves the room is the one that's going to take down that sign. So the last one in here, again, before we leave, so drive, and then right before we leave, we're going to lock southbound again. If we are the last one leaving, then we unlock the highway and unlock south. Okay? So what's the trick we're using to prevent things, southbound cars, from actually going in if there's a northbound car? There's a small trick we're playing. What is that trick? What is the first person doing in case there's other type of car going on? So if I am a northbound car, I go into the highway, I see there's southbound cars there. How do I stop other northbound cars from coming in? How are we doing it in here? Yeah.
Try to lock or unlock so we have to lock.
Yeah, so we're locking the highway. We're trying to lock the highway in here. When we see that the highway is not available, we're gonna sleep, right? But what are we holding while we sleep? The southbound semaphore. So if a southbound tries to come in here, it's gonna get blocked. Any southbound that comes in here is gonna get blocked off. So they're all gonna be, basically, in a sense, what you're doing is, if you go into the room and if you try to go into the room, you see there's a sign in there, you just put a block on the door, right? No one can come in. No one of your type can come in anymore. So let's go ahead and implement this. You have about 3 minutes. So I'm just going to use num southbound equal to 0, num northbound, and then we're going to need 3 semaphores. One is, call it mutex, north semaphore and south semaphore. So let's do initializations here. And north sem. So we just initialized everything to start with the value of being by default unlocked. So as we said in here, the first thing that we're going to do for the southbound cars is we're going to try to lock the southbound one. So we're going to try to do like something like some wait on south semaphore. We're going to increment the number of southbound cars. And then we check if we are the first one. So this means we are the first one in. And in this case, we try to wait on the mutex. Okay, so this is a direct translation of what we did. And after that, we're just going to do some post on south. Okay. Now, the exact opposite of this is going to happen at the end. Southbound minus minus We're gonna post to the mutex, and then post to south. So, okay. So this is gonna be the northbound one is gonna be an exact mirror of this code, except changing north to south or south to north. All right. So this is a direct application of the readers writers problem, or what we thought about in terms of the students and the janitors. Okay, so make sure you familiarize yourself with that pattern. You're comfortable with it, and ask questions if you are not. And that's it for today. I will see you guys on Thursday.